Today we're going to take a look at the synthesis or the combination reaction. And what we want to be able to take away from here is how to figure out what these two reactions are going to make if they undergo a synthesis reaction. So if you recall, there are 5 different types of reactions. The first one that we're going to focus on is the synthesis, or also known as the combination reaction. In this reaction, two or more reactants are going to combine and they're going to make one product. Okay. This is where the combination name comes from, where it's just two reactants combining together and you're making one thing. We're going to take a look at two scenarios here. When two elements react with one another, and another scenario where two compounds combine together. So if we're looking at two elements as our reactants, they are going to combine with one another. So depending on the type of element you have, you're going to have a different approach. So if both of your elements are nonmetals, we know that nonmetal and nonmetal combine to form covalent compounds where electrons are being shared. Now, the same nonmetal elements can actually combine in different ways. Depending on how the conditions of the reaction are, the same two elements can make multiple things. So to figure out what they make, you kind of have to study that branch of chemistry and know very specific reactions. So we're not going to really worry about that. What we do want to focus on is when the elements are a metal and a nonmetal reacting with one another. So if we have a metal reacting with a nonmetal element, then that's going to form an ionic compound where electrons are being transferred. So in order to figure out the product that these two elements are going to make, well, if it's ionic, then we just need to know the ions of the individual elements. And that's going to help us determine the formula for our product. So if we take a look at this example, I have sodium reacting with chlorine. And it's going to make an ionic compound. So if these are my only two elements reacting, sodium and chlorine, then my product has to be a compound of sodium and chlorine. So if that product, that compound, is ionic because it's got a metal and a nonmetal, then to figure out the formula of that product, I just got to take the ions of the individual elements. So sodium has a positive 1 charge as an ion. Chlorine has a negative 1 charge, so we're just going to do our crisscrossing method. And my product is sodium chloride because it's a combination of the two individual elements. Now, it may be tempting to write the product as NaCl2 because you see that the Na combines with the Cl2. We never transfer subscripts over. Subscripts are specific to each individual substance. The 2 here is originally present because chlorine is diatomic. So when chlorine is alone, it needs a 2. It's a molecule. But in terms of the product, because sodium's a +1 and chloride is a -1, I only need 1 of each in my ionic compound. It's okay that the subscript changes. You're not going to keep it the same. If it changes, so what? We'll balance the reaction afterwards because it's going to change. So what you need to remember here is you never transfer subscripts over. The identity of the ionic compound is solely based off the ions of the individual elements. If we take a look at another example, let's say we have calcium, and this calcium reacts with nitrogen. So I know my product is going to have to be a compound of calcium and nitrogen. So if these two things are going to react together, I need the ions of each individual element because I'm going to make an ionic compound with both of them. So calcium is a +2 as an ion, and nitrogen's a -3. So I'll just go crisscross these two ions. And my product ends up coming to Ca3 and 2. then again, it's okay that the subscripts changed because my compound calls for Ca3N2 because of the charges. I'll just balance my reaction afterwards to make sure that it's, the same on both sides. So when we take a look at the element-to-element approach, it's all about the ions. So we want to look at the cation, the anion, crisscross them to write our compound formula for the ionic compound that they're both going to make. Now let's take a look at the compound and compound combination, where two compounds actually combine to make one. These are very specific types of reactions. So we're going to focus on three. So the first compound and compound reaction, where they're going to combine together, we're going to look at a metal oxide combining with water. So a metal oxide is, you guessed it, it's a metal that's combined with oxygen. So when you have a metal that has combined with oxygen and you add water to it, it's going to form that same metal, but now it's going to be bonded to a hydroxide group. So in our example here, calcium has bonded with oxygen. So we have calcium oxide. Of course, this metal, arbitrary, you'll just substitute it for the name of whatever metal you're using. When calcium oxide has reacted with water, it's going to form calcium hydroxide, which of course the compound formula is dependent on the ions of calcium and hydroxide. Our second example is a non-metal oxide. So it's a non-metal that has bonded with oxygen added to water. So this is how we make acids. So if we take a look at carbon dioxide, okay, carbon, a nonmetal with an oxide, oxygen, bonded with water, we're going to make what's known as carbonic acid, where we're just kind of combining the entire substance together. Lastly, if we take a look at a metal oxide combined with a non-metal oxide, we're going to make an ionic compound. Okay, we're going to take basically the best of both, the metal oxide, the non-metal oxide, and we're just going to mash them together. And it's going to create an ionic compound of that metal with a new polyatomic anion. So these are very, very specific reactions, where you'll just kind of substitute the metal name, the non-metal name with whatever metal or non-metal is being used in the reaction, and they're going to always follow the same pattern.